Let's find the period of the function y equals cosecant of 2 pi x and sketch the graph of the equation. Actually, I'm going to use the sketch of the graph of the equation showing the asymptotes to enable us to find the period. So let's go back and review. The basic graph of cosecant of x, which is the reciprocal of sine, has vertical asymptotes whenever sine is 0. And as I mentioned in an earlier video, sine is 0 whenever x is 0, plus minus pi, plus minus 2 pi, and so forth. That's basic cosecant of x. Okay. We also know that the basic cycle for cosecant that we're going to choose to use here has asymptotes 0, pi, 2 pi, so this is one full period. Halfway between the first two asymptotes, it has a min of 1 and an upward opening shape, and halfway between the second two asymptotes, it has a max of -1 and the downward opening shape. And that's how cosecant behaves. So what we're going to do here to get what happens with cosecant of 2x is use my method of substitution. So 2 pi x is the argument of this function instead of x. So cosecant of 2 pi x is going to begin a cycle when 2 pi x is equivalent to the beginning of our basic cosecant graph. If I solve that for x, I get x equals 0 as the beginning. Alright, likewise, the curve ends a relevant cycle when its angle, 2 pi x, is equivalent to the ending angle of our basic graph. And when I solve for x here, I see that I get the value x equals 1. Okay? So this means that our graph actually looks like the following. From x equals 0, and I will make this x equals 1. Our beginning and our ending asymptotes, halfway in between at x equals 1/2 is our middle asymptote. Halfway between x equals 0 and 1/2 at 1/4 is our min of 1, upward opening shape. Halfway in here at 3/4 is our max of -1, downward opening shape, and that's the rough sketch of our new graph. But as I'd said before, if you can find where your graph begins and where your graph ends, the distance between where you begin and end is your period. So the period here is the absolute value of 1 minus 0, or 1 unit. So that's your period, and then we would look at a selection of graphs, pick out the one that has the correct asymptotes and the correct turning points, and you're usually will be able to do that in comparison to the other choices.